Everyone, this is going to be Unit 10 now. So Unit 10 is all about volume and surface area. So in order for you guys to be able to pick that up pretty easily, which I'm sure you will, we need to review a little bit what area is and our main shapes. So here we go. A rectangle. A rectangle is a four-side shape, which we call a quadrilateral, and it's made up of two parallel sides, and the two parallel sides are each perpendicular to each other. That's one thing. And what we do to find the area of a rectangle, basically, is we are cutting it into squares. So here's 1 row, 2 rows, 3 rows. They all should be equal. I'm not doing a great job. 4 rows. Doesn't matter. That will determine the problem. But this is what we're doing with every area problem. Each of these squares is 1 unit, whatever that unit is. So, how many rows do we have? 4. How many columns do we have? 7. So each is a unit, 1 unit, 1 unit, 1 unit, 1 unit. So 7 units, 4 units. And so our area is going to be 28 units squared. That's the idea. And that's where the squared comes from, squares. So if these were each 1 meter, 1 meter, 1 meter, then it would be meters squared. All right, so basically what we're doing is multiplying whatever the base is times whatever the height is. And that's where that idea comes from. Sometimes they call it the length and width, doesn't matter. Both work. And for a square is just a specialized rectangle. And all the two sets of parallel sides, they're perpendicular to each other, opposite sides are equal, and in this case, all sides are equal. And usually you'll see squares labeled with S. It could be X, it could be any variable. And there we go. Our area is going to be base times height. Same thing because it's a specialized rectangle. So S times S, S squared. That's where the squared idea comes from. All right, triangle. This is a little bit trickier, but cool. So triangle, as you know, is half times base times height. It's half of a rectangle, but I want to visually show that to you so you understand a little bit better. So basically what we're doing is, say I'm doing the height, and what is the height? The height is just the altitude, or whatever is perpendicular. Perpendicular height is the best way to put it. It's perpendicular to the base. So say did that, and I was looking for this section right here. If I made another section that's equal to this section, they're equal, and then I did this section and made another section that's equal. So if I call this A, B, B, A is equal to A, B is equal to B, you can see that this is just another base times height. Shouldn't use B then, that'll confuse you. But it's just base times height. So if I get rid of one of the triangles and another of the triangles, it's just half of that rectangle, right? And that's where the area becomes half times base times height. We're losing half of our rectangle. That's the idea. Cool. Parallelogram. Parallelogram is two sets of parallel sides. You can see the sides aren't perpendicular to each other. The opposite sides are equal though, but they're not perpendicular. That's the idea. So it ends up being a similar thing to the rectangle, but I want to show you why. So, say our height right here. Say I cut this piece off. I wish I could do that. Can I do that? Just this? Nope. Okay, never mind. I wish I could cut off a piece of it. So anyways, you're going to have to use your imagination here. So say I cut this piece off right here, and I put it over here. It would be the same thing. And then what would I have here? So what would I have here? what would I have here? It's just another rectangle. So that's the idea. This height right here would also be here, and it would end up giving you, again, base times height. That's the idea. So this would get put over here, and this height would get put over here. It's kind of sloppy, but you get it. I hope. If not, ask questions in class. I'll be happy to help you. All right, trapezoid is a similar idea. It's pretty cool. So let's just say, to give myself some room so you guys don't get confused as much as the parallelogram probably you did. This is also a height, altitude. It's going to connect with the base, except I'm going to erase this part so you don't get too confused. Oops. All right, so this is perpendicular. We're going to call this h, or the height of the trapezoid. So what is a trapezoid? A trapezoid is a quadrilateral. Quadrilateral means a shape with 4 sides that has one pair of parallel sides. So these are parallel. So we do have a trapezoid because we have one pair of parallel sides. We now have our height. So what we're going to do here is we are going to break this up into 2 triangles. 2 triangles. All right, call this triangle. No, let's not use letters. Let's use this triangle 1, triangle 2. Let's label the bases of each of these triangles. We'll call this A, and we'll call this B. All right, so since the trapezoid is going to be the area of both these trapezoids, both these triangles, let's do the area of triangle 1. Triangle 1 is going to equal 1/2 the base is A, times the height. How do we find the height? We need this. It's got to be perpendicular to the base. Do we already have that? We do. That's h. So there's 1. So now let's do 2. Triangle 2. Triangle 2, 1/2 times the base. Base is going to be B. And do we have the height? We do. Perpendicular to the base. So it would be right here. Same thing. Doink. Also h. So the area of the trapezoid, so we can label it as A for area, sub T, trapezoid. It's going to be triangle 1 plus triangle 2, right? So let's put in triangle 1. Triangle 1 is 1/2 AH, and triangle 2 is 1/2 BH. Technically that's correct, but we can simplify this a bit. Can we factor out anything from both of these? And if they're the same, we can. And there's 2 things that are the same, the 1/2s and the h's. So we factor out a 1/2 and an h, and we're left with A over here and B over here. And there we go. There's our area of a trapezoid formula. So you can see it written like that. You may have seen it written like this. H times A plus B all over 2. Same thing. I don't like it that way. What I like to remember it as, and it's easiest for me, is it's the height times the average of the bases. So the average of the bases, we add the bases together, divide by 2, and then multiply it by the height. This is the one I like. All of them work though. And there you go. So that's trapezoid. Circle you should remember. Circle, pretty easy, is going to be pi r squared, where r is the radius, right? From the center of the circle to any point on the circle. So all those are your area formulas. So let's do some problems here. Starting back on our worksheet, this is going to be your area formulas reference. You have a whole unit reference sheet in the beginning, so hold on to that. All we need is our areas for now. It does talk about perimeter a little bit, and just as a reminder, perimeter is distance around a shape, and we always use P for perimeter, and the only time we don't say perimeter for a 2-dimensional shape for the most part is when it has rounded edges, such as a circle. And for a circle, we use circumference, but it's the same idea. So let's do even problems here. Evens are usually a little bit more difficult. All right, so number 2, that's a triangle. We need the base and the height. We have it pretty easily. 1/2. Here's our base, 15 meters, and our height, 21.3 meters. How do we know it's the height? Because it's perpendicular to the base, and it goes to the other side of the triangle. So the vertex in this case. And when we multiply that together, we get A, meters times meters. Meters squared, 1/2 times 15 times 21.3 gives us 159.75. There we go. Circle should be easy. We know it's pi r squared. We need a radius. Radius is going to be half of the diameter, so 13 yards. So our area is going to be pi times 13 yards squared. And that's why we get yards squared, because we're squaring the yards and we're squaring the 13. So we get pi squaring 13, 169, yards squared. So we get 169 pi yards squared. That's your exact answer, but let's put it into a decimal. So that's going to be 530.92 yards squared. 93. Let's round up. There we go. Number 6, that is a rectangle. We know that because we have 2 sets of perpendicular sides, so which means these are parallel, which means the opposite sides are the same. So we get 3.7 kilometers times 10.5 kilometers. And that's going to give us kilometers times kilometers. It's kilometers squared. 3.7 times 10.5, 38.85. And there we go. Number 6, done. Number 8 is a parallelogram. How do we know? Because opposite sides are equal, which means, it doesn't tell us, it should, but that's the idea. And so now we know our height because 16.1 is perpendicular to our base. And now we just use our regular formula. So it's going to be area equals our base, whatever base we use, but since it's perpendicular to this base, we use this one, meters times 16.1 meters. Meters times meters is meters squared. 11.8 times 16.1 is 189.98. Whoops. There we go. Number 10. Number 10. Looks like it could be a trapezoid, but we got to know if these sides are parallel or not. And we know that because both those sides are perpendicular to 5 meters, and that means they are parallel. We learned that a while back. So we have our bases then. Those are the 2 parallel sides. And then we need some side that is perpendicular to the bases, and also the height of the trapezoid. So we have it, 5 millimeters, sorry. So our area is going to be our height times our average of our bases. Height times the average of our bases. So that's going to be 5 millimeters times 10 millimeters, which is going to be 50 millimeters squared. There we go. Now, if we went up here and did some of these, that would also be a trapezoid. Base, height. Number 7, we would have our base and our height. Number 9, we have our radius, and we would find the area of the circle, and since this is half a circle, we would just find the area and divide by 2. That's the idea. Number 12, this is a trapezoid. These are parallel. We know that because these sides are the same. That's something we'll learn later. We have the bases. Base, base. But we need the height. So I'm going to need to zoom in for this one. So we need to find what this value is. So we need to find x here. All right, what we can know, and this is a cool little trick, this and this are going to be the same. So this is going to be 7 centimeters. But we need to find this side right here because we're looking for x. But we can know this and this are the same because 10 and 10 are the same. That splits it in evenly. It means it's an isosceles trapezoid. So if the whole thing is 19, we have 19 minus 7. That gives us 12 centimeters. We have 12 centimeters between those two, which means each one must be 6. So now we have a right triangle to find x. So we get 6 squared plus x squared equals 10 squared, 36, plus x squared equals 100. X squared equals 64. And when we take the square root, we get x equals 8 or negative 8. Does negative 8 make sense for a height? No. So our x is 8 and our height's 8. That's the same thing because it's perpendicular to the bases. So our area is going to be the height, 8, times the bases average. So 19 plus 7 all over 2. So that's going to be 8 times 13. 13 times 8 is 104. And our units are centimeters, and its area, so squared. There we go. Number 11 would be pretty easy. It gives you the right triangle. So to find our height, we would just have to use the Pythagorean theorem as well. Let's do number 14. A parallelogram with an area. Ooh, it tells you the area. So we know area for parallelograms, base times height. Gives you the area. Has a height of this, find the length of the base. So area is this. Height. Base we don't know. Height we know is 7.5 inches. So to find the base, we just do division. B equals 160.5 inches squared divided by 7.5 inches. What's inches squared divided by inches? What's x squared divided by x? Just x, so inches. So we get just inches for our answer. And what's 160.5 divided by 7.5? It is 21.4 inches. That is going to be our base. There we go. Number 16. Find the length of a second base of a trapezoid with one base. All right, let's draw it. Sometimes it's better to draw it. Doink, doink. Oy, that was bad. So doink, 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 doink. Oy. Here's our bases. So find the length of the second base of the trapezoid, one base. So this is 12 feet. Height of 4. So this is 4. And we don't know this base. So the area is going to be 58. So we know the area for a trapezoid is height. Bases. So base plus base 1 plus base 2 averaged. So our area tells us it is 58 feet squared. Our height is 4 feet. And our one base is 12 feet. We don't know this one, and we divide by 2. Okay, we've got to solve for x. First thing I would do is get rid of the 4. 58 divided by 4 is, I don't know, 12, 48. It's pretty tricky. So 12 would be 48. Then 13, 52. 14, 56. And then 14.5 equals 12 feet plus x all over 2. So we got to get rid of the 2's on both sides. So we multiply both sides by 2. And we get 29 feet equals 12 feet plus x. So subtract 12 from both sides. We get 17 feet equals x. And there we go. We just got to work our way backwards. Number 18, going into perimeter. So a square perimeter one's easy. We know each side's the same. So to find the perimeter, all we need to do is find one side. So the area of the square is just going to be s squared. So if the area we already know, that's not too bad to find. What's s going to be? So s is going to be the square root of 361, which is 19. So if s is 19, the perimeter is going to be 19 plus 19 plus 19 plus 19. So the perimeter is 4 times 19, which equals 76 feet. Nice. Fun. Okay, last one. Application problem. Mr. Payton would like to paint his deck. The dimensions of the deck are shown below. If 1 can of paint covers 72 square feet, how many cans will he need to purchase for 2 coats of paint? Oh man, if 1 can of paint covers 72 square feet, how many cans will he need to purchase for 2 coats of paint? Meaning, a coat of paint means you covered the whole deck in a paint. So that's 1 coat. And if you do it twice, that's 2 coats of paint. So he's saying, how many times, how much paint is he going to need to cover the deck in paint twice? That's the idea. So first we have to find how much area is this deck. So the area of the deck is going to be the height, the average of the bases, so that is going to be 313.5 feet squared. So that is the area of the deck. 1 can of paint covers 72 square feet. So let's find for 2 coats of this deck. So 2 coats of this deck would be 2 times the area, which would be 627, sorry. 627 feet squared. That's how much we're going to be covering. So if 1 can of paint is 72, we're going to have to do 627 divided by 72. And that's going to give us, we're going to need 8.7 cans of paint. Can you get a 0.7 can of paint? No. So you're going to have to actually get one a little bit more so you make sure you can cover everything. So you're going to need 9 cans of paint. And there we go. All right, guys, that's section 1.